Good afternoon, everyone. My name is David Lapsley. I'm the lead of engineering at MetaCloud. MetaCloud is part of Cisco Cloud Services. Today, what I'd like to talk about is some of the work that we've been doing to add real-time statistics to Horizon. At MetaCloud, we provide OpenStack as a service. So what this means is we create and maintain private OpenStack clouds for our customers. We have a very experienced engineering and operations team. Our operations team will install our distribution of OpenStack on our customers' hardware on their premises, and then after the initial installation, we continue to monitor and maintain that deployment 24/7. It's really like a SaaS-based delivery model. So our customers only have to worry about running their clouds, managing their users, and we automatically update the software, troubleshoot their cloud without them having to do anything. One of the things about this model, it delivers tremendous value to our customers, and our customers really like the fact that they can run OpenStack without having to manage the underlying cloud infrastructure. It's slightly different, though, for our customers' system administrators. They're actually used to being able to log into individual devices on the network, individual servers, SSH into them, have sudo access, and be able to see exactly what's going on. With our model, we manage all of that, and so they don't have that access. And so one of the challenges for us is to be able to provide them with enhanced platform visibility. This is really important to our customer system administrators. One of the ways that we're trying to address this is by the addition of a new feature that we call live stats. So live stats basically instruments all of the servers in our cloud, and it enables us to see the current state of a server at a particular point in time. Here's an example of what a live stats screen looks like. So this is actually looking at the live stats for a particular controller in one of the clouds. So as soon as you go to live stats, you'll see an overview tab. That tab will give you a snapshot of what the server is currently doing, and it'll update every 5 seconds. So on the overview tab here, you can actually see information about the system. You can see the uptime for the system. You can see the physical configuration, so the number of sockets, cores, and threads. You can also see information about the CPU utilization and the breakdown of the CPU utilization. You can see information about the memory, total memory usage, and the breakdown of that. And you also have information on network I/O, the amount of data that's going in and out of various network interfaces per second. We also provide information about disk usage too, so you can see at a glance how much your total disk storage is, how much is currently being used, and how much is free. In order to do this normally, you'd have to log into one of the servers, type a few commands. With live stats, you can actually see all of this through the UI in a very simple manner. Here's a controllers panel. So the controllers panel actually allows you to see all of the controllers that are currently in your network. So the way that you actually activate live stats is by clicking on the View Live Stats button to the right of the controller that you're interested in. So again, here's the overview data, which you pop straight into once you click the button. If you click on the Processes tab, you can actually see the top 50 processes that are running on a server. You can sort it by any one of the columns there. So typically what you'll do, if you're trying to find out which processes are actually using resources on your server, you'll click on either memory utilization or CPU utilization, and it'll automatically sort, and you can see the top resource users on that server. This is the Live Stats networking panel. So here you can see a breakdown of the number of packets that are going into and out of different network interfaces on your server. You can see error counts, you can see packet counts, and so on. It's really useful for system administrators to see this. It also updates every 5 seconds, so you not only see the current state, but you see it constantly updating. And this can be very useful if you're trying to troubleshoot, for example, network issues and see error counts incrementing. We also provide real-time disk data as well. So you can see even more detailed information about the disks on the server. So in addition to being able to see the total space available, the total size of a disk, you can see the total amount of space that's free and also what's currently being used. You can also see things like read counts and write counts, and you can see data throughput as well. So now what I'd like to do is talk about how we actually implemented live stats. So the first step was to actually instrument the cloud. So what we've done is actually, so this is actually what a cloud looks like. So we have, at a high level, we have our redundant controllers at the top there. We have hypervisors at the bottom there. Each node in our network is running a LiveStats daemon, which will enable you to query the server and see what the current state of the server is. Whenever a user request comes into Horizon, Horizon will then go out to the appropriate server, pull the information from LiveStats, and then present it to the user and update that every 5 seconds. This is a little bit more detailed view of how we implement this. So on the back end, so if you look at the hypervisor on the far right there, we actually run LiveStats as a WSIGI process running within gUnicorn, and we have URLs as a RESTful API that you can actually access there to pull various bits of information about the server from. In the middle, you have the controller there, and the controller is running Horizon within a WSIGI process within Apache. We have two different URLs that the requests come into. So one is the request for the view, which goes into the view endpoint there. And then you also have the data resource, which ultimately is pulling the information, presenting it to the front end in JSON, or presenting it to the client side in JSON, which then gets rendered as HTML, and pulling data from the back end hypervisor there. So in addition to instrumenting the cloud, we also needed to make enhancements to Horizon so we could present this data in a really interactive way and in a way that was easy for us to extend. So this is what a base Django stack looks like. So you have requests coming in at the top from the web browser, going into the Django stack. Then those requests go to the URL dispatcher, which maps the requests to a view. So within the view, you have a function that's actually serving that request and responsible for constructing the response. That view will then go to a model layer, which is an abstraction layer that presents information as Python objects instead of whatever the underlying database happens to be. And then at the very bottom there, you have the database, which can be MySQL, PostgreSQL, or any other database. And then once you get the information from the database, it propagates all the way up through the model, through the view, which then gets templates to actually tell it how to render the page that then gets returned to the client. This is what the Horizon stack looks like. So there have been a number of enhancements to the basic Django stack. So all of those boxes in green there are enhancements that have been made to the basic Django stack to enable Horizon to make it easy for engineers to be able to extend the functionality of Horizon, implement dashboards and panels and views that manage OpenStack resources. So the main differences here are you've got the client-side JavaScript at the top of the diagram there, which provides some interactive capability. You have data tables in the middle of the view there, which are one of the most fundamental components of Horizon. Those data tables contain a lot of functionality that enable you to present OpenStack data in a way that the user can interact with. Underneath the view, you have the API. So one of the differences between Horizon and other Django applications is that it's pretty much stateless. So it doesn't maintain its own database. And the reason it does this, or it doesn't do this, is that it doesn't have the cache coherency problem, where it has to maintain coherency between its database and the OpenStack databases. So we have an API layer there, which makes it really easy for us to make calls into the back end, into the OpenStack services on the bottom there, without having to do too much work at all. So the blocks in yellow here are the extensions that we've actually added to Horizon, which enable us to add features like LiveStats easily in a way that's really interactive and easy to extend. So the biggest component here is the REST API in the bottom right of the diagram here. So this REST API, it sits on top of the current API, so we can pull data through the current API using any of those API calls. We also have access to Graphite and also to LiveStats daemons. So we're able to pull that information from all of those different sources and then present it to the front end, where we have client-side model view controller using AngularJS. We've also extended the data tables module of Horizon, and this means that it's actually really easy to add this additional functionality into Horizon. So we have 3 different mechanisms by which we can extend Horizon now. The traditional way, using existing Horizon, predominantly server-side classes. You can extend it this new way on the right-hand side there, where we have client-side MVC on top of a REST API, or there's a third hybrid way where you can extend existing horizon functionality by inserting into the hooks that we have in data tables there. So we've done all of this work, and so the question is, what was the motivation? Why did we go and do all of this work? Well, it turns out that if you enhance platform visibility, it means our support engineers or our operations teams get many fewer support calls from the customers, because our customers can actually see much better what's going on in their network. So rather than calling us to figure that out, they can actually see that. And ultimately, that means we're able to scale our operations, because if we're getting fewer support calls in, that means we can manage a much larger cloud base than we would otherwise. So if any of this sounds interesting, we are currently hiring. We'd love to hear from you. So please, there's our jobs website. Please go to our jobs website. We have positions for platform engineers, for UI engineers. We have a great team there, and we work really hard and we have a lot of fun. We work on some really interesting and cool stuff. And all of the stuff that we work on goes into production, which is pretty neat. So please have a look at that. There are my contact details, so my Twitter handle, my email. If you're interested in any of this stuff, please feel free to email me or contact me on Twitter. I'd love to hear from you. Thank you.